Hi, good morning, guys. Happy Monday, week 2 of virtual learning. Expectations are that you guys copy down the problems and then you pause when I ask you guys to and make sure that you're doing the work yourself, okay? Not just waiting for me to give you the answers. So please pause the video and read your do now, please. All right, so this is a fun do now, and I actually looked up the stuff to make sure it was historically accurate. In World War II, mortars were fired from trenches, which were 7 feet down. So a trench is something in World War II, and it's below, ground level. The mortar, which is a weapon, you can see in the corner here, is shot with a velocity of 36 feet per second. So the scenario for this would be y equals negative 16x to the second power. We know that's gravity. Initial speed goes next, 366x, and then because it's 7 feet down, the starting height would be -7. The maximum height of the mortar shell, we can do this all on Desmos. So what I'm going to do here is pull up the Desmos screen and just plug in the equation that I used. So I have negative 16x to the second power plus 366x minus 7. And when I get something that looks like this, I might need to zoom out and click on all the stuff that I can see. So in the beginning, the dots that I would click, -7 is the starting point, y-intercept. 0.098 is 1. 22.856 is another x-intercept. And my maximum is going to be right here. 11 seconds and 2,086 feet. So the maximum height in 11 seconds, it will reach a maximum height of 2,086 feet. All right, how long will it take for the mortar shell to hit its ground level target? If I look and drag my mouse down to ground level, it's going to be the target at the end, and it's going to take 23 seconds for it to reach a height of 0, which will be on the ground. So it's going to take 23 seconds for it to hit the target on the ground. Our learning log today is I can solve systems of linear and quadratic equations. We've already done systems, and we've done that with linear equations where I give you a graph, and you might have something that looks like this, and you need to find the point of intersection. The only difference today is that I'm going to give you one linear and one quadratic. So you're going to have to figure out maybe 2 points, 1 point, or no points where they do intersect. Do now, guided notes, go formative, exit ticket is our agenda. All right, so a little bit of review. We don't have guided notes like I planned because it's going to be virtual, so I just need you guys to take this down on notebook paper. So if you guys remember substitution, you guys can pause the video and solve this as well as the elimination problem. So go ahead and try to do that now. All right, your answer. So substitution is when I take two values that are the same and I take one out and I put one in. So since these are both y, I can set them equal to each other. On one side, I have 2x minus 5, and because y equals y, I substitute the y for what it's equivalent to. When I solve this, real quick, just make sure that I'm doing this correctly. These cancel. I have 6x. Bring down all my terms. And then to get 6 by itself, I add 5. These cancel. 6x equals 6. And when I divide by 6, my answer is x equals 1. I'm going to pick my easier equation to figure out what y is. That's my easier equation, I think. I'm going to take 2x, but instead of x, I'm going to put my x value here of 1 minus 5. 2 minus 5 equals -3. So if I have x equals 1 and y equals -3, that is my ordered pair solution. So 1, -3 is where those two lines are going to intersect, something like that. All right, moving on to elimination. Elimination is when all my variables line up. So I have x here, y here, and my constants here. So elimination would be the easier one to solve. I want to cancel one of them. You can do x or y, but I'm going to do x. To cancel x, since this is a negative 2, I want this to be a positive 2x. To get it to 2x, I multiply by a positive 2. When I distribute it, it becomes 2x plus 2y equals negative 2. That's just from distributing it. I bring down the top equation. And this is called elimination because when I add them together, these eliminate. I'm left with 5y equals negative 5. And from that, I can deduce that y equals negative 1. It's half my answer right here. So I need to go back and figure out what x is. I'm going to use my easier equation. I think my easier equation is the bottom one. And I'm just going to plug in negative 1. So I have x plus, and instead of this y over here, I'm going to plug in negative 1. And this is equal to negative 1. When I solve to get x by itself, add 1 to both sides, and I have x equals 0. So my final answer for elimination should be 0, comma, negative 1. All right, so that was just a brief overview. This is all review of linear equations by substitution and elimination. We're going to use the same methods, but with quadratics today. All right, so what it looks like as systems of linear and quadratic functions is what you see right here. So over here, you want to copy this down, maybe something that looks like this. Copy it down on your notebook paper. Make sure that you copy down the 2 points of intersections. And since there are 2 intersections, we're going to say that this has 2 solutions. Go ahead and copy down the second image. And you're going to write that this, because it has 1 intersection, is going to have 1 solution. And our last one, you see that there are no intersections. So after you copy down that graph, please write that it has no solutions. So just like linear systems, that is the difference. The intersections are going to be called solutions or answers. All right, so method 1, this will be important in your do now, so take this off, take this down on your notes. Method 1 is going to be through Desmo, so this is really easy. All right, our page here. Okay, so go ahead and take the time, and I want you guys to pause the video and put these equations, both of them, into Desmos. All right, now when you do that, you should have something that looks like this. You're going to click on all of these points, and it's going to give you all of the important information that you need to know. Right here is the y-intercept for the blue one. Right here is the y-intercept for the quadratic. We have the minimum, the vertex here. We have, what else? We have the x-intercepts. And right here, though, is the important information, where they intersect. So go ahead and star these points. These are the intersections. And that is what's going to be the solution to your problems. So the solutions are where they intersect. And those points where they intersect, the first one right here is 2, negative 4. Sorry, negative 2, 4. And then the second place where they intersect is going to be your second answer. And that is 2, 0. So that was easy. That's Desmos. Go ahead and do the second one. Remember that where they intersect is going to be your solution. So let's say it looks like this. This will be your first solution, and this will be your second solution. So go ahead, put those into Desmos and see what you get. When you do that, you should get these answers of all of these numbers, your final answers for your solutions, your intersections should be negative 2, 9 and 1, 3. The rest of them are important, but those are not considered intersections or solutions. And then your last problem is number 3 on Desmos. Go ahead, pause the video and do that. All right. And when you do that, you should see, are there any intersections? No. So this one would be no solution. All right, nice and simple. All right, our second method is substitution, and we know this from before in an earlier unit. We substitute and replace equivalent terms. So remember what we were doing before. If I have a y here and a y here, I would circle them, for example. I would take one of them out, and what was equivalent to y, I would plug in. That's the same thing that we were doing here. All right, so we already did these problems. We already did all of them on Desmos. This one right here, this number 1 matches the one that we're going to do again, but now we're going to use the method of substitution. All right, so same problem. And we already know the answers. We already know the answer is going to be negative 2, 4, and we already know the answer is going to be 2, 0. We're just going to prove it using substitution now. So since these are both y, I'm going to take out one of the y's and I'm going to plug in what's equivalent to it. So when I set this up, on one side, I should have negative x plus 2, because that's what y is equivalent to. And on the opposite side, I'm going to have x squared minus x minus 2. If they both equal y, then they have to equal each other. When I solve quadratics, I want them to equal 0. So I'm going to move everything to one side so that the whole thing equals 0. That means I need to add an x to both sides. And that means I need to subtract this 2 from both sides. When I do that, these cancel and these cancel. So I have my goal of setting it equal to 0. And remaining on this side is x squared. Negative x plus x is 0. Or I don't even have to write that because they just cancel. So cross out, they cancel. And then negative 2 minus 2 is negative 4. All right, do you guys see how a b value is missing? Well, when the b value is missing, I can solve using square roots. So instead of writing plus negative 4, I'm just going to write this as minus 4. All right, and to solve for x, I can just add 4 to both sides. These cancel, and now I have 4 equals x squared. To do the inverse, I take the square root. And remember, there's 2 answers for square roots. X is equal to 2, but also it's equal to negative 2. So my final answers for x are 2 and negative 2. So I'm going to erase that. Remember, have this copied down. So x is equal to plus and minus 2, but I need ordered pairs. So basically, I have x equals 2 and x equals negative 2 as 2 of my ordered pairs. I pick my easier equation of the 2 and I just plug in these values. So for the first one, I'm going to do negative and then this positive 2. Negative 2 plus 2. Negative 2 plus 2 is 0. So when x equals 2, y equals 0. Let's do the same, but for negative 2. For this one, I will do negative 2 plus 2. Negative 2 is positive 2 plus 2 is 4. So when x equals negative 2, y equals 4. These are both my answers. And you'll see the first one right here is down here, 2, 0. And then the second answer right here, you see, we've already figured it out on Desmos, is the top answer. So that's how you do it via substitution. All right, the second one, I'll help you guys set this up because they're both equal to y. I can take this out and I can put this in its place. That's called substitution. When I do that, my equation is negative 2x plus 5 equals 2x squared plus 1. I want to get this all equal to 0 on this side, so I do the opposite. I add 2x and I subtract 5 from both sides. When I do that, these cancel, so I'm successful in getting it equal to 0. And then I have 2x squared. I have plus 2x, and these are what can combine, these two right here. 1 minus 5 is negative 4. All right, when I do this, this is a quadratic and it can be factored. So I have the 0 in the front. I'm going to factor out a 2 because there's a GCF of 2. So when I factor out 2, what's left over is x squared plus 1x minus 2. And then from there, it's just a level 1 problem. So 0 equals 2. I set up two binomials, throw an x in both of them, and what multiplies to equal negative 2, but adds to equal 1. Think about it for a second and put your final answers down. All right, so I figured out my answers are negative 1 and positive 2. They multiply to equal negative 2, but add to equal positive 1. And final step, when I set all of these equal to 0, my x values become x equals 1 and x equals negative 2. All right, so I have x equals 1 and x equals negative 2. Make sure you have all of this down. And all I do is plug it back in to the easier equation. I think this bottom one is the easier equation, but you can use either of them. When I plug in 1, my y value will end up being 3. You can double check too. And when I plug in negative 2 here, go ahead and plug it into your calculator or Chromebook or whatever. You should get a y value of 9. And how do I know that's true? Because we already did it on Desmos and it matches the intersections that we've gotten already. All right, last one is substitution. I'm gonna let you guys try this on your own. Oh wait, okay. So this one we already checked on Desmos and you can't do it because we already decided it had no solution. So if you guys work this out, you would figure out through algebra that this one also cannot be factored and there's nothing that you can do to solve for a solution. All right, so I'm gonna leave these two on the screen. You can pause the video and work this out on your own and then double check with Desmos. When you do that, number 4 should be the answers. 7, 114, and negative 6, negative 42. I just threw the Desmos screenshots on here. And then number 5 should be negative 2, 2, 8, 42. All right, and then now we have Desmos and substitution down. I think we have one more method, and that is elimination, which we've already done before as well. A lot of people thought that this was their favorite method, so let me show you how it works with quadratics. Remember, the x's are lined up, the y's are lined up, and the constants are lined up. I want to eliminate one of the variables, so I have to multiply either one of them or both of them by a number so that one of the variables cancels, and then I can solve for the variable that's left over. All right, so elimination. Remember, we want everything to be lined up so that we can cancel something. So the y's are lined up, the x's are lined up, the constants are lined up, and there's no exponent for both of them. But the easiest thing for me to cancel out here is the y's. All I have to do is multiply one of them by a negative 1. And when I do that, this bottom one becomes negative y, and then negative 1 times this is positive x squared. Negative 1 times this is negative 39x. And then negative 1 times 64 is negative 64. I drop down the top equation. And I want to line them up. So I'm going to put the 20x here and the 120 underneath the 64. When I do that, what eliminates is the y. Perfect. And this is set to 0 now, which is what I wanted my goal to be in the first place. Drop down to x squared. Negative 39 plus 20 is negative 19x. And then negative 64 plus 124 is 60. This is a level 1 question. I need to find out the binomials. I can throw an x in both of them. And real simple, what multiplies to equal 60 but adds to equal negative 19? Go ahead and pause the video and figure that out. When you do that, you should get 15 and 4, and then the signs for both of them will be negative. I set them equal to 0, so this is all procedure by now. And then my answers are x equals positive 15 and x equals 4. Make sure you have all of that down. Negative. Wait, what was it? Negative 15 or positive 15? Oh, okay, so they're both positive. X equals 15, x equals 4. And then, just like substitution, I pick my easier one. I think this one's easier. And I plug in the x value. So when I do this, and I do 20 times 15 plus 24, 20 times 15, all I'm doing is plugging it in, plus 124, I get, I did that wrong. Make sure you're using the correct signs. 424, so x equals 15 when y equals 424. I do the same thing. My second value, I'm gonna plug this into my easier equation. You can use a calculator, that's fine with me. 20 times 4 plus 124, and I'll get a y value of 204. So those are your two answers. Your first answer, your first solution or intercept is 15, 424. And then your second one is 4, 204. All right, two problems for you to solve. Remember, we want to get these right here to cancel. So basically, all you do is multiply one of them by a negative 1. My recommendation is you multiply this by negative 1. You multiply the one that doesn't have the exponent. You want to keep that positive because it's easier to factor. All right, so go ahead and pause the video and try to figure out your answers here. All right, now when you do that, let me cover up these numbers because they're kind of confusing. All right, when you do that, you should have multiplied this top one by negative 1. That's because you want to keep this positive, okay? If you would have multiplied the bottom one by negative 1, this would have resulted in a negative 2x squared, which is much harder to factor. So again, try to keep that positive. This becomes negative y equals x minus 3. When you do this, these eliminate, which is great. So I get 0 equals x squared plus x, and then 1 minus 3 is negative 2. When I factor these, I throw an x in both of them, and now what multiplies to equal negative 2 and adds to equal 1? That's going to be negative 1 and positive 2. So when I set both of those equal to 0, my answer should be x equals 1 and x equals negative 2. When I plug in both of those values into my easier equation, something like that, do this on my calculator. So I'm going to plug in the 1 first. So negative 1 plus 3. So when x equals 1, y equals 2. And then my second one, I'm going to plug in a negative 2 value. So using this equation, I have negative 2 plus 3, and I should get 5. So when x equals negative 2, y equals 5. These are my two answers, and hopefully it's going to match what I have. Yes, it does, negative 2, 5, and 1, 2. Using the same method, number 8, there was an 8 there, should have been -1, 1, and 2, 4. You can always double check using Desmos. Remember, our 3 methods were Desmos, substitution, and elimination. All right. I know I went through that kind of fast, but your Go formative, 1 through 9, please, please, please try to honor this. I want you to do calculator inactive. So it tells you to use elimination, and it tells you to use substitution. However, you may use your calculator only to double check. For 1 through 9's calculator inactive, and then I'm going to let you 10 through 15 use Desmos for the remaining portions of the problems. Lastly, these ones, we haven't necessarily done them before, but I want you to read the instructions of how to do this on Desmos, and you guys are smart. You guys can figure it out. Please do not forget, as your agenda, you need to do your Go formative and your exit ticket before you finish today's lesson. All right, please reach out if you guys have questions, and yeah, that's it. Thank you.